I hope you have enjoyed the last 9 chapters during this learning PlantUML in action. From this video is we move to the chapter 10, timing diagram, which is the last chapter or last type of the UML modeling. We will totally talk about the 10 types of the UML modeling. After this chapter, we finish the UML related diagram, then we will move to another 10 types of the non-UML related diagram. So I hope you keep your momentum and follow me with this chapter 10. After this chapter, I believe you will have full confidence to draw almost all kinds of the UML diagrams, I believe. So, although the UML diagramming have the evolving their standards, but this 10 type of the UML diagram really provide enough insights for you to design in your day-to-day work. So come to this chapter, timing diagram is not easy the chapter, so we try to explain this in subchapter by chapter. This video is we will using two samples to demo you how to declare the element or participants in timing diagram. Within that is we will introduce you total 7 different the notations. First 5 are different type of the way that you may draw the timing diagram. So you can have this clock. So the number 3 have the binary, the number 2, and also analog is the last one, and the concise is like this notation, and the last but not least is the robust. So most of the time is you may hear about concise and robust in the timing diagram, but you may also need to practice others, clock, binary, and analog. And also we will have our the keywords is change means this using this at you can follow the with our timing digits. Then this you can define like this at 0, at 50, at 100, at 300. So at which the timestamp is you will have some timing status change. Then you will use this change keywords. Another keyword is. So we have learned similar things as when you define our element name with our alias, you use as. Within timing diagram, we introduce a verb is. So then let's go to our content and in the mind map. So let's first have the mind map show you. So it's quite many the diagram contents here. I have some wordings just trying to show you in the beginning. So think of our timing diagram as an inward sequence diagram. So that is most of the time is people compare sequence diagram with a timing diagram. So sometimes it's also people learn sequence diagram first, then learn the timing diagram later. So sequence diagram is more popular. So you can remember is that is like a vertical lifeline. But timing diagram is you can consider that is 90-degree rotate for our sequence diagram. So the Excel for the timing is in the Excel. So in the timing diagram is time passed on the Excel from left to right with different constituent components of the system that interact with each other on the y-axis. So on the y-axis, you have the different components that can be the different department or different type of your concept. Timing diagrams show how long each step of a process takes. Use them to identify which step of a process require too much time, and then that is the improve or the optimization areas that you can evaluate. So I also gave you our link for the this Wikipedia, so you can read some more background, and you can use those to go to the different links about timing diagram within the UML. So that is enough initial background. So if you don't familiar with the timing diagram, you may come to the wiki page. Always I add our the classification, which I borrowed from Visual Paradigms, this product websites. But this classification actually is also introduced by the UML standard. So you may see we have 7 structural diagram, and we have another 7 behavioral the diagram. So timing diagram actually is positioning here. So it's one of the behavioral diagram, and subclass is the interaction the diagram. Sorry, I have a double I. And within this interaction diagram, you may have some similar things like in sequence diagram, and also we have a communication interaction overview diagram. So, and then there's a timing. We have learned a lot earlier about the sequence diagram. So now for every drawing, try to revert your memory back with the sequence, then try to feel is what's the different implementation or presentation way from the timing diagram. So that is, I hope will help you to learn this type of the diagram better. So let's come to here. So first is we have these 5 keywords. I don't repeat that. Is I hope you can read these and then this you can understand the definition. So let's directly go to this 0, 10, 0, 1, the first one. So P is extension is no difference. PUML and syntax is still the start UML and end UML. So why I mentioned this here is because when after this chapter we move to non UML type related diagram, you may see here this the starting and end the programming syntax will be changed. Like is if you want to draw a mind map, that will be a start mind map and mind map, not UML. So that is the thing. At least for the 10, the UML related diagram chapters, these syntax are keep consistent. And then let's look at this diagram. So we have a web server, and web server have 3 different state, the waiting mode, processing mode, or idle mode. So and we have a web user. Web user can be the idle or watching, waiting. So if the web browser is the look field is the web user is idle, then web browser is idle. But if web user do something or trigger like certain events, then this web user is on the waiting mode until there is any the result. But on the web browser is it can be processing and waiting something. So that is just a portion of the activities. But you can consider is if you draw this like a sequence, they have idle waiting have a certain sequence, and idle processing waiting is also a sequence. But now in the timing diagram, we put that in the convert with 90 degrees. So X and Y is a difference. And on every dotted line, vertical line, represent a equally interval of the time. So if you see here is our interval is 100, then this two interval altogether will be 200. Then this number 3 will be the 300. So that is the key components, and the web server and the web user are the different keywords with the, or we can say that is the element. So let's starting to see here. This the line-based notation is we call that robust. So robust complex code is as a complex line signal. And this kind of the notation is called concise. Concise is a simplified signal. So you don't see they have a different height. They just change this sequence by the different states. So whether or use the robust or concise is depending on your real case. So if you don't need to have this comparison of the height between the different the participate, then you can just use the concise. Let's see. So within the star and the UML, we can first is do the definition part is robust. So let me have the preview. And then you give double the quotes. So if you don't have this double quotes, if you just give WB, that will introduce this one because robust is the keywords for timing diagram, so it's no misleading. So it just directly draw this one. But you want to see that should be the web server instead of the WB. So then you can have the alias use AS keywords. So web server or web browser as. Then here we will show the name and no worry now you only have one interval because we are not using the at to define the timestamp. So and the second is concise. So you can see you can use web user to define the second one. So same is well, we will have alias. So alias is if you use as is, it's the same. So not case sensitive. And then we start is we are starting to define the at 0, at 100, at 300. But if you put in those, you can see because you don't point 200, 400, so they only have these numbers on the interval point you have defined, and they extend another interval just to ensure is your line is not the showing incomplete. Then what you will need to decide is on different timestamp what will be happened. So for time 0, we have the web user starting to have idle, and we also have our web browser has the idle. So what we have make is a web user, and then here is the keywords is. So we just select the natural English language is web user is idle. So then we will introduce this state. So because it's the concise, so it's starting to create our idle concise notation. But since we don't have any another state timestamp is this idle will be assumed is to the most right end of your diagram. So at the 10, so you can do the two ways of your timing diagram. One is you design the one participate from left to right or from the beginning to end. Like I'm thinking about the web user's behavior first. So web user do something from 0 is idle, from 100, no matter it's a unit, maybe that is 100 milliseconds. He or she is go to the waiting mode. So you can do that is first within the 100 you make RWU web users another activity state change. All you think about is all the participate state happened on the every timestamp. For example, is when you design the timestamp 0 at 0. Not only have our web user, but also have something happen to web browser. So then is you switch to another participant. So that is depending on your knowledge coming. Is if you're coming from the full participate status per this timestamp, then you can do the second way. Or you, if you interview one participate, like is you interview web user, the web user feedback to you. For example, is whole the working states from beginning to end. Then you may first define web users the full different states at different timestamp. So, but for this sample, I just trying to do that from the follow this way. So at time 0 is we have web user is idle, and also we have a web browser is idle. Then this idle is create our robust. So robust is also like this concise. There's no any other status change than this coming to the most right end. But on the this second, the at 100, 100 you can see web user is changed to waiting. So then from that is web user is waiting. Then that will make the cross. Then is change this status to waiting, and the web browser change to processing. So it's have our one another line. So and to second 200 there's nothing happened, and 300 is the web user doesn't change anything. It's still waiting, but we only have a web browser finished processing. Now web browser is waiting. So that is the way is you can use this add combined with is to define the different timestamp behavior. So that is the first very basic timing diagram, and let's do this second one to show you some other notation. So let me create a second file. So 0, 1, 0, 0, 1, 2. So let's examine here. We have two clock, one binary, one concise, one robust, and one analog. So we should define all of them. So first is, let's see, so clock, just use the keywords, so clock. And then the clock 1 or 0. So clock 0 as C0. So for clock is you finish this alias definition will not create anything, and the syntax is still waiting for more parameter. So for clock you need to at least give our parameter period. So that period is if you see 50, then this clock will have half of 50 to the positive, half of the 50 to the negative, or you can say half of 50 go to the digit 1, half of 50 go to digit 0. So that is the clock, like our these binary things. So then we can have using the with. With is the keywords and the period 50. So that will create our 0 to 50 to 100. Then this your period. Period is the one complete cycle is the 50. So within one period you have one half positive, half negative. But this is by default. If you don't change that, is have a pause and offsize, it will just the 50-50%. So the second clock will not be this the average clock. So clock 1. So as C1 with period. So we have the same period figure. So period is still 50. But now you can see clock 1 and 0 are exactly same length. But we have our the pulse can introduce. So I put pulse 50. Then this 50 will be the of this 50 will be positive, and the rest of the things now is the 50 minus 15 is the 35 will be the this negative. So if you think is you can see here is I put 10, then the positive is shorter, then that means 10 of 50 is 20%. So that is you can compare is 20%. Now rest of that is in the level 0 or negative will be the 80%. So that is the pulse means. And then this offside. Offside 10. Offside is to shift to the right with 10. 10 is also 10 off 50. So if you have here is the 100, then you can feel this shift will be the exactly 10%, and the pulse is the 15%. So that is the starting point you can define by this offside, and the pulse is defined the percentage of the negative positive compared to the negative on these portion parts. So now you have two the clock, but because we don't have any other the at, so by default it's just to give you two period. So you define period is 50, then they give you 100. If I define the period is 100, and this also extend to one another minimum the period, so it's go to 150. So that is just ensure is you have your diagram will be displayed complete if you have something is showing in the most right end. So that is the clock. Binary is just something is can only show 0 or 1. So but is binary is not like a clock is with the period. Binary is you define binary yourself. So binary as B. So that can be seen here. By default, I think is as our 0 level. So, but it's from left to right, and we can define at which time is it can be come to the 1, for example. So concise we have learned. So concise as C. So we have the empty now because we don't define anything within the concise and the robust. So just have these areas and last but not least is analog as A. So analog is like the continuous link. So you can already see this light, the very thin, the gray the lines for that. Now we have six the components, two type of the clock here. So let's starting to define some timestamp. So on the zero, the timing. So you don't need to change anything to the clock anymore because clock is already defined by period, pause, and offsites. So they just follow the your timeline. But you need to define C concise, R robust, and A analog. So let's say C is the concise from zero is I will change to idle. So that sentence is just C is idle at zero. So it's a very direct the language. So now I have displayed this idle until the most end. And for the robust, we can see that is the by the way, so we don't need to define binary because binary is in the default level. So we will change binary to another level is when we have that timestamp. And then this robust we need to see is also starting from the idle. So R is IDLE. So we have a line for robust. And then the A is the analog. We have our zero line. Or is if you see you want to have 5 lines, so then this go to the 5 as the initial value. So let's have this 0 value first. Then as continue, so if we see we move to 100, so at 100, so which is change? Binary is change. B is high. So by default is low. So when I say binary is high, then this change this level from low to high. And then this we can see here the concise. C is waiting now. So C is changed to waiting. And then we will have our the R is processing. So like the earlier sample, first sample. And then the A is 3.0. We don't need to have 3. The data point 0 is already the analog. And then at 300. At 300 is binary, doesn't change, but let's change is go to low. So let binary down again. So you can see that can be like this electric level. So you can control that is in high or low. So and then the second is concise is idle again. So let me see is changed to idle. So then that's make that more better. So but the robust is now waiting. And also analog is what is 1. So it's like changing the level. So then from this, you can see the two clock is just keep extending because they have their predefined period, pause, and offset. This 3 parameter is already defined the full detail of the clocks, so you don't need to change that. And you can use the clock to as the certain the background standard to measure the other type of those timings, the diagrams notation. So we start is I hope is you get initial idea is on what are the timing diagram the looks like, and what are the key elements or participants and their definition, and how to draw the initial timing diagram and putting those notation in, and how to change the levels on the different type of those notations. And this is the finish for this 10.1. Next one, we will have a quick the video is to talk about the binary and the clock especially. So see you in the next part. Bye for now.